Now this is turning moment and flywheel. We will solve one numerical problem here. This is Anna University questions. It can be asked in Anna University also, other universities also. So the turning moment diagram for a 4-stroke gas engine is given by 4 triangle areas. So 4 triangle areas A1, A2, A3, A4. This is the turning moment diagram. Torque, turning moment versus crank angle. Suction stroke area is given 0.43 into 10 power minus 3 meter square. Compression stroke 1.72 10 power minus 3 meter square. Expansion stroke 6.75 10 power minus 3 meter square. Exhaust stroke 0.6 in 10 power minus 3 meter square. 1 meter square area energy is given in the question equal to 2 meganewton meter of energy. Right? In the area, 1 meter square area is 2 meganewton meter of energy. Assuming uniform resisting torque, find the mass of flywheel rim. We have to find the mass of flywheel rim. Radius of flywheel rim is given, it is 1.2 meter. Maximum and minimum speeds are flywheel maximum and minimum speeds N1 and N2. N1 is 204 rpm, N2 is 200 rpm respectively. Right. So here, this is the crank angle diagram, turning moment crank angle diagram. A1 is the suction stroke area, A2 compression stroke area, A3 is the power stroke or working stroke or expansion stroke area, A4 is the exhaust stroke area. So net area equal to work done per cycle. So we have to find the net area. So these areas A1, A2, A4 are negative, A3 is the positive area. Therefore net area is equal to A3 minus of A1 plus A2 plus A4. So add this 6.75 minus of 0.43 plus 1.72 plus 0.6 into 10 power minus 3. It gives you net area is equal to 4 into 10 power minus 3 meter square. 1 meter square is 2 into 10 power 6 Newton meter, because here it is given 1 meter square area is 2 meganewton meter, that is 2 into 10 power 6 Newton meter. 1 meter square area is 2 into 10 power 6 Newton meter. Therefore, work done per cycle is equal to net area, that is 4 into 10 power minus 3 into 2 into 10 power 6, because 1 meter square equal to 2 into 10 power 6, right? Our area is 4 into 10 power minus 3 meter square area, right? Therefore, work done per cycle is this thing, 4 into 10 power minus 3 into 2 into 10 power 6 Newton meter. Work done per cycle is equal to, we know the formula, mean torque, T mean into theta, crank angle. Crank angle in 1 cycle, that is 4 pi radians, 2 revolutions. Therefore, this becomes 8000. 8000 equal to T mean into 4 pi. Therefore, T mean torque, mean resisting torque is equal to 636.94 Newton meter. So here we know that N1 is equal to 204 rpm revolutions per minute. Therefore, omega 1 angular velocity at maximum speed 2 pi into 204, 2 pi N1 by 60. This is equal to 21.35 radian per second. N2 minimum speed 200 rpm. Angular velocity omega 2 is equal to 2 pi into 200 by 60. This is equal to 20.93 radian per second. Angular velocity at minimum speed. Mean speed of the flywheel omega 1 plus omega 2 by 2. Omega 1, this is 21.35 plus 20.93 by 2. Therefore, mean speed omega is equal to 21.14 radian per second. Right. Now, radius of the flywheel rim is given 1.2 meter. Coefficient of fluctuation of speed CS is equal to omega 1 minus omega 2 by omega. We know that coefficient of fluctuation of speed CS equal to omega 1 minus omega 2 by omega. 21.35 minus 20.93 divided by 21.14. This is equal to 0.0199. So this is the coefficient of fluctuation of speed. Right. Now here you see that work done during power stroke is A3. A3 area is the work done during power stroke. Therefore, work done during power stroke, work done in power stroke equal to A3 area. A3 is given 6.75 into 10 power minus 3 meter square. Right? Therefore, this work done is equal to work done during power stroke equal to 6 meter square is 1 meter square equal to 2 into 10 power 6 Newton meter it is given. Therefore, 6.75 into 10 power minus 3 into 2 into 10 power 6. Therefore, work done in power stroke work done during power stroke is equal to this area into meter square, right? 1 meter square 2 into 10 power 6 Newton meter. Therefore, work done during power stroke is equal to 13.52 into 10 power 3 Newton meter. So this is the work done during 13.52 into 10 power 3 Newton meter is the work done during power stroke. Therefore, work done in power stroke is equal to half into T max into pi. You see this? Work done during power stroke is this area A3. This is the A3 area of the triangle. Half into base into height. Half into height is T max, maximum torque. T max, base is height is the maximum torque T max, base is pi. Therefore, half into T max into pi. This value is 13 point, we have found out 13.52 into 10 cube. This is the work done during power stroke. So, from this we can find out maximum torque T max. Maximum torque T max is equal to 8611.46 Newton meter. This is the maximum torque. Right. So, maximum fluctuation of energy delta E, del E is equal to half into dE into Ag. Right. Half into dE into Ag. Right. We have to find out the value of dE. Triangle ABC and triangle AD are similar. ABC, ADE are similar triangles. Therefore, similar triangle DE divide by AG is equal to DE divide by AG is equal to BC divided by AL. BC divided by AL. So DE, similar triangle, right? DE for the small triangle, DE divided by AG is equal to BC divided by AL. DE divided by AG. AG is T max, maximum torque minus mean torque. T max minus T mean. So T max minus T mean equal to BC value. BC is pi. This is BC, this is pi. Pi divided by AL. AL is maximum torque, Tmax. Therefore, DE we can write like this. DE is equal to, DE divided by Tmax, maximum torque on 8611.46 minus mean torque is 636.94 equal to BC pi divided by BC pi divided by maximum torque 8611.46. So from this you can find out DE is equal to 2.9 radians. So we have found out for the smaller triangle DE, this value DE 2.94 radians using this equation. Therefore, maximum fluctuation of energy del E is equal to half into BE, half into DE into AG. Right? See, this is the area of the triangle. Del E is the area of the triangle ADE. This is the maximum fluctuation of energy, half into DE into AG. Therefore, del E is equal to half into DE 2.9 radians we have found out. AG value Tmax minus Tmean. Tmax minus Tmean, that is 8611.46 minus 636.94. This is AG, right? Tmax, this Tmax minus Tmean, this is AG. This is AG. Therefore, del E is equal to maximum fluctuation of energy we have found out is equal to 11,593.88 Newton meter. This is, we know that maximum fluctuation of energy I omega square CS. I is equal to mk square omega square CS. This is del E. Del E is equal to mk square, I equal to mk square. But here k is equal to r, radius of gyration is equal to radius of the flywheel rim. Therefore, del E is equal to m into r square omega square CS. Del E value 11,593.88 is equal to mass of the flywheel, m equal to, where m is the mass of the flywheel, into r square 1.2 whole square, because instead of k I have substituted r. Radius of gyration is equal to radius of the flywheel rim. It is radius of flywheel rim is given, into omega square. Mean angular velocity, we have found out mean angular velocity 21.14 whole square into CS 0.0199 is the coefficient of fluctuation of speed, right? Del E is equal to m r square omega square CS. From this, mass of the flywheel rim can be found out. M is equal to 905.32 kilogram. This is the mass of the flywheel rim. 905.32 kilogram is the mass of the flywheel rim. Right? We have found out the mass of the flywheel rim. Right? From the given equation, from the given problem.